And dear students, in the last session we have discussed about this YouTube manometer to find the pressure of a liquid with the help of a measuring fluid, namely the mercury, which is used to measure the gauge pressure. And for this we applied the logic that at the same height the pressure of left hand side will be equal to the pressure of the right hand side. In this session also we are going to find with the same principle the pressure, but here the pressure is not the pressure of a one fluid, but the differential pressure of two fluids. So now you can see this diagram. There are two fluids. One fluid is indicated in blue color mark, which is nothing but my A. The liquid is A, and there is another liquid, namely which is shown in black color, which is nothing but called as B. Now this liquid A also has certain pressure. Now liquid B also has what? Certain pressure. Now what is the difference between PA and PB? It can be either PA minus PB when PA is going to be greater than B, or it can be PB minus PA when the pressure exerted by B is more than what? The pressure exerted by A. Okay, so now we are going to find the differential pressure, that is the difference between two pressure of two different fluids, or it can also be the same fluid but at two different pressures. It can also be of same fluid but at two different pressures. Okay, so that is our idea. So now let us take the fluid A or the liquid A. Generally we used to take as water. If you are not happy with water, you can take any liquid. There's no doubt in that. You have the full freedom to take any other liquid also other than water. Let us now, for the example, let us take it as water. The blue color mark is nothing but my water, and the liquid B is nothing but my oil. The liquid B is another oil which has a specific gravity, say 1.2, which means its density is above water, because this density will come around 1200, because we know the specific gravity is given by density of the liquid by density of water. So this value is equal to 1.2, means 1.2 equal to density of liquid by density of water, which means it is 1.2 into 1000, because we know the density of water is 1000. So the rho L will be equal to what? 1200 kg per meter cube. So we now come to know the density of the another fluid. Let us take an example. The density of the liquid B is 1200. As soon as we have taken the density of A is what? 1000, because we know it's a water. So rho of A equal to what? 1000. Rho of B equal to what? This is nothing but rho of B equal to what? 1200. Now I want to know the A will also exert some pressure, B will also exert some pressure. Now I want to find the difference of pressure. That pressure is called differential pressure, and the corresponding manometer is called as differential U-tube manometer. And the corresponding manometer is called as what? Differential U-tube manometer. And generally it is advised to have a measuring fluid whose density will be greater than more than this fluids. So what is the specific gravity of mercury? This is nothing but my mercury. It is nothing but mercury, Hg. This red color indicates what? The C indicates, this we can call as C also. That the C indicates what? Mercury. So this mercury is having a specific gravity of 13.6, which means its density of mercury will be 13,600 kg per meter cube. So compared to the other two liquids, its density is very high, nearly 30 times higher than almost both the liquids. Okay, so it is, we can see this that much of density we should have taken. Whenever you are using a normal U-tube manometer, we have to use a higher density fluid as a measuring fluid. When you are going to use a inverted U-tube manometer, then you have to use a lighter fluid. That will come in the next session, not now. Okay, in this session, always we have to use a measuring fluid. Here, the red color indicates the measuring fluid that should have density what? Higher than the other two fluids for which you want to measure the pressure. Okay, let us move. Let us move further. I hope it is clear what we are going to do it. We are going to measure either PA minus PB or PB minus PA. Can someone tell me where the pressure at both the left hand side limb and the right hand side limb will be same? Any idea? Where the pressure at the left hand side limb and the right hand side pressure will be same. So I can draw like this. Where this mercury ends, from here I can draw a plane. As you told is right. it is XX. It is what? This plane is what? XX. And I'll mark this point as E and F. Whatever point you can make it, I'll call this point as what? E and F. If you want, you can put a D and E also, nothing wrong in that. So in this place at E and F, since both is the same liquid and both are the same height, what is the inference you can tell now? What is the inference? Yeah, you are right. Now what is the inference you can tell? The pressure at E should be equal to what? Pressure at F. Because both are what? Mercury, both are the same height, which means the pressure at E should be equal to what? Pressure at F. This is the principle we are going to use to find the difference of pressure between these two liquids, namely A and B. A and B. We'll proceed further. It will not take another 2 to 3 minutes. We'll complete it. So first let us try to find what is PE. What is the pressure at the point E, which will be equal to what? PA. What is the pressure exerted by A plus this height. Let us call this height as what? This height, not the whole height, this height. Why I classified this height? Because up to this only the liquid A is there. Up to here only the liquid A is there. So this H1. So what are the remaining column is nothing but what? My mercury H2. Okay. So let us call this H1 as what? H of water column. We'll call this as what? Head of mercury column. That is the height. Okay. Otherwise we can leave it. Just we can have H1, H2. Nothing wrong in that. And similarly, from the center point of B to this height, we can call it as H3. We can call this height as what? We can call this height as what? H3. Now let us try to find what is the pressure at E. So the pressure at E on the left hand side will be equal to the pressure exerted by the liquid A, so PA plus rho of A into G into H1. So up to here we got the pressure now. But still we are not at the point E. So we have to add this also. What is that one? Plus rho of mercury. Because here the red color mark is what? Mercury. So rho of Hg. Into G is common. Into what? H2. What is H2? What is the measurement we are going to for the have the height for this H2? So I hope you are very clear with this. I will repeat once again. I want to find the pressure at E. This pressure at E will be equal to the pressure exerted by the liquid A. So PA plus rho G into H1. So H1 is up to the water column alone or the liquid A only. So this side is H1. So rho A into G into H1. Rho A is, we are considering is water, so it's 1000. If you are considering any other liquid means you have to put this corresponding density. That's it. Plus still there's a height H2. That H2 is there. Into G. Into what is the density of this fluid? It is mercury. So rho of Hg. So I hope it is very clear. So very simple. Now let us come to the other side. Let us come to PF. What will be PF? Can anyone tell me what is PF? Yes, you are right. Yeah, we have to start from PB. I am coming from this side on the RHS. PB. There's only one fluid. Plus, I can call this as what? Rho B. Because this is the density of this liquid. Namely, in our example, it's coming as 1200. Into G. Into what? H3. Into what? H3. Now you balance these two equations. What is two equations? PA. Yeah. I can make it what? PE equal to what? PF. Because that is the principle we are using. Because we know the pressure at E and F are same. So P equal to PF. Which means I can equate these two things. So I will write like this. Which will be equal to what? PB minus rho B G into H3. So this one is what? PF. This one is what? PE. We know P equal to what? PF. So from this, you know rho G H1, you know rho Hg G H2, you know rho B G H3. So only unknown is what? PA and PB. We can't find both, but we can find either PA minus PB or PB minus PA. If this value, if you are going to find PB minus PA means, if it's going to be negative means, for example, in this equation, I am trying to find PB minus PA. If it's negative means what is it means? PA has higher pressure than PB. If it's positive means what is the meaning? If the value is coming to be positive means what? The pressure of B is more than what? Pressure of A. So this we can't tell whether the pressure of B is more than A or A is more than B. According to the answer, if it comes as positive means whatever the condition you have taken is correct, which means pressure of B is more than pressure of A. Let us consider these two cases. Let us have PB minus PA is what? Positive, which means PB is greater than PA. On the other hand, we are going to have PB minus PA as negative, which means PA is greater than what? PB. So in this type of differential manometer, we can find only the difference of pressure between the two fluids, and we can't find the pressure of a single fluid. This type of manometers are required mainly to find the differential pressure of the two fluids. Now there may be one question for you. The question what I have drawn here, the level of A and B are not the same. B is somewhat below compared to A. A is little above, B is slightly below. Sometimes even B can be still below. So it doesn't require that A and B should be at the same level. Okay, I hope it's clear. Dear students, now let us see a problem on differential YouTube manometer, which is supposed to find the differential pressure between two fluids. Two fluids may be of the same fluid or may be different fluid. What do you mean by of same fluid means both A and B can be water. A can be water, B can be oil. A can be oil, B can be water, or both may be of different fluids. This is also oil, this is oil of different specific gravity or same specific gravity. So, in this particular problem, we are going to find the difference between PA minus PB or PB minus PA. Both are one and the same. So, in this case, we are going to take A as water, whose density is 1000 kg per meter cube, because they given the specific gravity as 1, and the mercury specific gravity is 6. So it will be equal to 13,600 kg per meter cube, and the specific gravity of this given fluid B or oil is 1.5. So its density will be 1500 kg per meter cube. Heat density will be equal to what? 13,600 kg per meter cube. This density of water is 1000 kg per meter cube. So how to find the difference between A and B? Since it's a normal YouTube manometer, we have to find the datum at the lowest possible. So here the water is getting separated from the oil at this height, but still we can move down because it's a normal YouTube manometer. The datum can be fixed at this particular height where both are mercury. So we know the principle that PC equal to PD. Based on this formula only we are going to solve this problem. It's very simple. So the pressure C will be equal to what? Pressure D, because we know both are the same height means the pressure will be same. Now let us try to find PC. How to find PC? It's nothing but PA plus rho of water, that is of rho of A, into G into H of A. H is up to here only. So the remaining height is also what? Mercury. So we have to add this mercury also, plus rho of mercury. Got it? This is also, we are finding up to C, not up to here. So up to here only is what? 0.7 or HA. So this is what? 0.2 is there. So rho of Hg into G into this 0.2 or H of Hg. H of Hg is nothing but what? Height of the mercury column in the left hand side limb, which is equal to 0.2. So this value is equal to 0.7 meter. This value is equal to what? 0.2 meter. So this is the left hand side. So I hope it's very clear. PA plus rho of water or rho of A into G into HA. HA is nothing but what? 0.7 meter. Then we have to go up to C. So we want this one. This is occupied by mercury. So rho of mercury into G into H of mercury is nothing but 0.2, which will be equal to, because this is PC. Now I am going to write the PD. PD is I have to move from here. So it is PB plus rho of B. Rho of B is what? 1500 into G 9.81 into what? This height. This height is nothing but what? Center of this B up to this one 0.6. So you know what is rho A? 1000. You know G 9.81. You know 0.7. Otherwise I'll write one more step. So PA plus 1000 into 9.81 into 0.7 plus rho Hg is nothing but 13,600 into 9.81 into H of mercury is nothing but 0.2, which is equal to PB plus rho of B. Rho of B is nothing but what? 1000 into 9.81 into 0.6. So from this, the only unknowns are PA and PB. So you can either find PA minus PB or you can find PB minus PA. I hope you will solve yourselves and let us know the values. Okay. So I hope you enjoyed the usage of the differential YouTube manometer to find the differential pressure between two fluids or be of the same fluid of different pressures. Okay. I hope you enjoyed it. Thank you.